All right, we're going to answer question 8 in your notes, which is finding the area of this segment. And so remember, that is what a segment is. So you are going to draw your two radii of this circle by connecting O to A and O to B. We create this triangle AOB. And so we also created a sector AOB, and that, remember, is that whole slice of that pizza. So in number 8, you're going to have to add in a little part to your directions here, and I'll tell you in just a minute where that is. It says, look again at the circle, and suppose the radius is 9 inches. So that tells me from O to A is 9 inches, and O to B is also 9 inches. AB, the length of that segment, that's why there's not a segment bar there. So from A to B, this whole length is 11.6 inches. And arc AB, the arc, has a length of 12.6 inches. Now remember, that's not arc measure. Arc measure would be in degrees. So it says to draw a perpendicular from the center of the circle to, and then it doesn't tell you what to draw it to. So this is where you need to add to your notes. We're drawing it to segment AB. So we're drawing a perpendicular from O to AB, and you have a little point there already, and that's perpendicular, and you're labeling that point of intersection as P. Now, the reason why we did that is because our very first step in finding the area of the segment, and there are 4 steps to do this. And so it's quite time-consuming, but none of the parts are especially hard. They're all things that we've done before. So it's nothing new in these steps. It's just you have to do a lot of steps to get to the area of the segment. So the reason why we drew in that perpendicular is because our first step is to find the area of triangle AOB. And so we know to find the area of a triangle, it is 1/2 the base times the height. So we just created a perpendicular relationship where we can use this segment as the height and this segment would be the base. So we know our base is going to be the 11.6. That is the distance from A to B. But we've got to find the height. And so what we're going to do is we're going to look at this right triangle APO, and we know the hypotenuse, because that's the radius of our triangle, is 9 inches. Now A to P, using prior knowledge, we know when we have, we could extend this segment and make it a radius. So when a radius is perpendicular to a chord, we know it bisects that chord. So we know A to P and P to B are both half of that 11.6, or in other words, they are 5.8 inches. So we know one leg, and O to P is what we're trying to find as the height of that triangle. So the very first thing you have to do is first find the height of your triangle. And to do that, you're going to, in this case, use the Pythagorean Theorem. So we're going to have h squared plus 5.8 squared equals 9 squared, the hypotenuse. So we can find 5.8 squared in our calculator. We know 9 squared, so we have h squared plus 33.64 equals 81. And we can subtract 81 minus 33.64, and that tells me what h squared is. Now h is, we know, found by taking the square root, but we don't want to take the square root of 47.36 because it's not a perfect square. And we don't want to round our answer yet, okay? We don't round our answer until the very end. So you'll write yourself a little note here. That'll be helpful. Round at the end, not along the way. So if you round your answer in step A, step B, and step C, you've gotten farther and farther away from your correct answer. So you always wait to round until the end. So we're going to leave h as the square root of 47.36, but we're not going to actually put that in our calculator. So now we're ready to find the area of the triangle 1/2 base times height. We already wrote it's 1/2 and our base is 11.6. And now we know what our height is. It is the square root of 47.36. Now again, I'm not just going to type that in my calculator because remember that's an irrational number. But I can go ahead and simplify half of 11.6, which is 5.8. So we get 5.8 square roots of 47.36 as the area of the triangle. All right, so now we're going to, in step B, find what fractional part of the entire circle we're dealing with. And so remember, when we talk about finding the area of a sector, we know it's a portion of the whole circle, and we're trying to figure out what portion that is. Well, since we're given the length of the arc, we know our fractional part is just the length of that arc compared to the circle's complete circumference. So circumference is 2 times pi times the radius, or pi times the diameter. We're given our radius is 9, so the whole circle has a circumference of 18 pi. So our arc length, remember, was given as 12.6. That's the part of the circle's circumference we're dealing with. This is the fractional part we want. Now again, I'm not putting this in my calculator because pi is irrational, and I don't want to round yet. I don't round till the end. Now I'm going to use that fractional part to find step 3, the area of a sector. So we know the area of a sector is simply the fractional part of the area of the circle. Now how do we find the area of a circle? That's pi r squared. We know our radius is 9. 9 squared is 81. So 81 pi square inches is our area. So we want this fractional part of that whole circle. Now, I can put this in my calculator, and the reason is, even though it has pi in there, notice this pi in the denominator will cancel out that pi in the numerator. Now, I do want to show you something to be careful about when you put this in your calculator. Do not put in your calculator 12.6 divided by 18 pi like this. The reason you can't put it in your calculator like this is your calculator thinks the only thing you're dividing 12.6 by is 18, and then you're multiplying that answer times pi. And that's not what you want. You want 12.6 divided by that product. And so you need to put the 18 pi inside parentheses, and now your calculator knows, oh, you want me to divide this by that product. So there's 12.6 divided by 18 pi, and we're multiplying that by the whole area of the circle, which is 81 pi. Those pi's will cancel, and I don't get an irrational number. I get a terminating decimal, 56.7. This is an area, so that would be inches squared. This up here, this area would be inches squared. This circumference, fractional part, that's just a fraction, so we don't need it. But on our circumference, I've been leaving off my units, but I'll go back and put those. So now the area of the segment is found by just taking the area of the sector, that whole pizza slice, and removing the area of this triangle. And so when I take away the area of the triangle, that leaves me with the area of the segment. So it's the area of the sector minus the area of the triangle. That gives me the area of the segment. So we've already found these things. The area of the sector was 56.7. We're subtracting the area of the triangle, which is 5.8 square roots of 47.36. Now I can put that in my calculator because I'm rounding at the very end. So I'm going to put in the 56.7 minus the 5.8 square roots of 47.36, and I find rounded, so I'm putting approximately equal to. We're rounding to the nearest tenth, I believe is what it said. I don't see the directions, but I know it's to the nearest tenth, so that would be 16.8. And this is area, so that would be inches squared. That's the area of the segment. So again, there's lots of steps, but each one of them are things that we've done before. Nothing is new in here. We just know the area of the segment is found by this difference here. So on your homework, you're going to have to use those 4 steps on number 1 and number 3 both. And so make sure you show those steps that you're doing along the way.